So we will continue with the Internet of Broken Things, and then I will talk to you about, or then we will kind of make a summary on what actors and sensors we learned and kind of try to finish up with them. And then I'll show you a little bit how to use LEDs, because one or two of you might incorporate that in their final project. Then I will talk to you about the final project, or maybe I switch the two things around. Okay, so to round up what we have started with the security last time. So I want you to do a small research exercise on if the Internet of Things can be fixed, the Internet of Broken Things can be fixed, if we can prevent it. So I want you, and now we have full 15 minutes like initially planned here. I want you to come up with 3 action points that when addressed will fix the Internet of Broken Things, and we can call it Internet of Things again. And 1 argument for continuing to use and build the Internet of Things, because there will be actually 2 of you will helping me later, and we will try to defend against the rest of you that we say here in front that the Internet of Things is broken, and you will convince us that it is not. So we'll make a mini discussion here, and I hope I can convince 2 of you to argue on my side, because else I might be destroyed as a teacher here in front and the others against. So you will practice that a little bit, kind of for 5 minutes. I want you to discuss with the neighbor and increase the number of action points. So my hypothesis here in front, and the hypothesis of 2 of you, is there kind of 2 people who would like to study in the other direction? Is that 2, would that, can I select 2 who join me, or are there 2 volunteers who would join me later in front? I just don't want to be alone when I argue against the rest of you later. Is there somebody who doesn't want to research for is it fixable, but wants to research why it's so broken? Come on, I also might pick some here. Okay, you help me kind of saying that everything is bad and broken. 1 more person. First row. Somebody would like to help me? Can argue against the Internet of Things? Okay, we say 3 persons, 1 from each row. So you have to, this row has to figure out 1 person, and you guys have to figure out 1 person who comes in the end to me. So because we will actually do that, the hypothesis, we should abandon all work with the Internet of Things and only focus on classics. So basically on mobile devices and industrial building automation, and not use any sensors in agriculture. These things go into your research report, and then we will discuss this here together. So we have 15 minutes plus 5 minutes for you to prepare, and then we will fight against each other. Go. Okay, so sometimes in the class I make a big debate. You maybe saw in the last slides that I had this alternative lecture, and I kind of let you fight each other. We don't have time this time for it, but I wanted to have a little bit of a critical reflection on what we are doing, and I like to do that in debate style. So I hope you at one point get a chance, or have had a chance, to run a real debate where you take a position and try to defend a hypothesis, or argue against an hypothesis. So we here in front will now, and I will be a little bit the moderator, and we will try to argue against each other. But my hypothesis here today is we should abandon all work with the Internet of Things and only focus on the classics. So only do some stuff with mobile devices, and in terms of automation, only focus on things happening in industrial settings. But no home stuff, no kind of measuring. That's all way too critical, what is going on. So we argue here actually in front, and then you get some space to argue against. Security is one of the main concerns. What are the other concerns? Privacy.
Stability of the systems.
No, let's kind of say all of them. So stability, and you had another point?
Updatability.
And updatability, yeah? So because all of that isn't solved, we think we should not consider too much in the Internet of Things. There was another nice point one of you brought and said, anyway, all these kind of technical devices and all the data we create is just harming our planet, and there's too much storage going on, so that's kind of a bad thing in itself. So that's why we should not do the Internet of Things. What are the arguments for it, and how do you think you can fix some of the problems we have said? Oh, we win! We win!
One point I've read that should help with the security problems is the lack of standardization. That is happening at the moment.
So you think having good standards would kind of take care a little bit?
Standards definitely help.
So mean like the development with Wi-Fi now to go to the new Wi-Fi 6 or so, or how we call it, 5G goes in the right direction?
In general, more standards, and also standards which include hardware-led approaches.
Okay, but standardization could actually help mitigating some of the problems. Other things which could fix and convince us to are in favor of the Internet of Things.
Finding some stakeholders that are responsible for issues and solving those problems.
That's a really cool point. I never heard about that. So defining the stakeholders and kind of building some kind of expert task force group which really addresses some very specific problems of the ones we just raised. Yeah. Okay.
Force manufacturers to go open source.
That's a good way. You say that for me, don't you? No, go open source and make things auditable and transparent so that people can actually at least react if threat vectors are found. Very interesting. Now, do we have kind of something to fight against this? Does it really solve our security issues we have with this?
Yeah, the main problem is that there are so many devices out there already. So we don't have these implementations and won't have these implementations in the next few years. That alone won't save the security problem.
Okay, that might be a long-term solution they have provided, but it might be already too much out there. It might be already broken, so it doesn't fix what is already out there. I think that's a good point. Do you have something to fight back? Or some other point? It's fine too, if you...
Just because we did it the same way for many years, we can't say we have to continue with this approach forever.
Do you have some ideas how we could kind of tackle this issue that there's so many broken things already out there? Like the zombie webcams or so. There's so many people who bought these really cheap security cams, and they are all attackable and kind of are used actively in attacking infrastructure. How do we deal with the legacy stuff? Help your colleague.
This is a very interesting question because I'll give you a very interesting example.
In Brazil or what?
Do you know COBOL? COBOL? The language? Okay, you don't know COBOL. Yeah, he knows COBOL.
They might have talked about it. COBOL is a language which comes up pretty often in software engineering and kind of our sins we have done, yeah.
It's a very old one, but all the banks in Brazil still using COBOL because of because of the legacy systems. This is the way they deal with the legacy things.
Yeah, but what is their solution? What is their solution to get this into new systems? Same for you.
Yeah,
you learned that, didn't you? Yeah.
In Austria, the Cobalt core or Fortran core is updated once a year because they don't want to break things.
Oh, it's actually cool that they're updated. So what I have learned with the Cobalt story is we wrap that nicely in some modern interfaces and then access it from the outside, but the core functionality still continues running somewhere. And I think that's a good argument you can make against us. You can say we can also contain some of the old hardware in kind of firewalled networks and prevent the access from the outside. So even if we don't update some of these devices, there are mechanisms in network technology how we can tackle these problems.
You can like isolate the whole network.
Yeah, careful not arguing too much against ourselves, yeah? No, but you're right. Okay, some other action points to fix the Internet of Things. Yeah, okay, you told us, yeah, we have to introduce some architectures, we have to introduce some layers to fix it. Good idea. What about privacy concerns? Did you find something to deal with privacy concerns? How can we prevent everything spying on us? Why do we let everything spy on us? Because we are convenient, yeah? So we like things spying on us because we get something for it and it makes things easy. But can we fight back there? Do we want to fight? Maybe you can also say, create a cultural shift, we just accept that everybody is spying on us.
I don't think the problem is that the people don't know that things spy on them.
Yeah.
And as you said, they usually are convenient.
Yeah.
And the trade-off is one they like to take. So they say the value is worth more than the day-to-day gain.
So you think we will create a cultural shift and just deal with it?
Probably. Or some people fight back and kill the robots that spy on them.
But you have seen kind of these activities around purism and kind of these private phones, and they have lots of hard times to actually establish something. But I think there are activities to address privacy concerns. So, or I've been working a lot with a free voice assistant, and maybe you could say, hey, open source might be actually a solution to some of that concern, kind of enabling locality, enabling not having to use the cloud. So one argument on my case, so if everything is in the cloud and all the devices are connected to the cloud, we have lots of potential for single point of failure. How can we mitigate the single point of failure issues? Because we have everything in the cloud. Sorry, I kind of took your argument probably away. That happens if you are the moderator. You often don't give enough time to your... How can we fight the star topology phenomenon? What would be the action point there? So you have to think about about Kai's talk, Kai Werner. What is the solution? The hybrid integration platforms. Yeah, kind of to build these different layers into the system, to think about clear definition between edge computing, fog computing, and cloud computing. And actually do some things on the edge, and so that also helps with kind of all the resources and what actually goes into the cloud. Any other points? Okay. Thanks a lot for kind of supporting me here, so that they didn't pull me to shreds, but they actually didn't try. I think we stood a pretty good ground here, so I'm not completely convinced yet, but as I'm a teacher of Internet of Things, I still think that the measures we have seen are very worth pursuing, and if we are strong in that, we might be able to keep the Internet of Things alive without breaking the whole world. Okay, thank you. You can go back. So if you look at the literature, yeah, they actually say if you develop Internet of Things systems, and they say also security is the biggest threat we have there, you have to emphasize security from day one. So basically, if you build a new Internet of Things system, think about security, else you might be automatically develop a broken system. Think not only about the features, but also the life cycle. Think about what your system does when it runs. So that kind of binds back to what we do here with the stories, yeah? Play through some stories in advance and think what are the life cycle steps of the product you are actually building. Think about updates. Think about possibilities to change, stay agile, react on things. Yeah, don't make a closed system and think, okay, this video webcam is done, and then 10 years later you wonder why they are all used to attack your own infrastructure. Yeah, make it possible to update. Think about fine-grained access control. Yeah, not all devices just need root access. Might make sense if there are different access levels. Know your enemy. Something overlooked very often. So who is actually interested in attacking? And I think if you talk about privacy, maybe there is not really an enemy or so. So maybe if we look in a good way, of course we know governments are using the data, Amazon and Google or Baidu is collecting about us, or Telegram is collecting about us and uses that for politically influencing us or kind of destabilizing countries. But important is to think who can even do something with the data. Because Amazon will probably mainly use the data to sell us more stuff, and is that so bad? No, so we can discuss that. Be prepared. Have a plan B. Yeah, if you have a factory or a vineyard or a kind of agricultural big thing or mining operation, you have Internet of Things, yeah, be prepared if somebody attacks your infrastructure and be able to deal with it. Have some IT persons on site, kind of get some reports from the devices if something weird is happening. Have monitoring dashboard systems to actually look at that stuff. Okay, you have kind of gathered a lot of things. So I try to summarize this once more. So what can you do against it? What are action points? So one is awareness building. So what we are doing here in class is, I hope after this class you will know that Internet of Things is cool stuff to work with, but there are problems. You should be aware now, and maybe some of these textbook advice things like what I showed you, you might keep in your mind and use when you design a system. Then one point I always want to drive home is don't think just in the star topology. Think in layered systems. Think that there's more than the border of your factory or border of your house where you can change something. There might be something in your house, in your factory, on your field. There might be several different gateways or firewalls in between, or kind of architectural decisions you can put in between. Then I really like your open source point. I think building a community and extending outside of the initial stakeholders might be very important, because if you have lots of people being concerned and testing, you might also see more mistakes and be able to fix them easier. So it might be very important to have a community around that and actually share. Maybe there's another vineyard who does also tech stuff to produce better wine. That might be, you might have to perceive this institution not as your enemy, but maybe as your partner, and you could use the same software and both prosper better. Again, openness about core infrastructure, allowing audits, being transparent might help mitigating problems. You have lifecycle management, maintenance. I built in something for maintenance. So do something with predictive maintenance. Use actually the devices to check on themselves. Think about encryption. Yeah, so we talked a little bit about that. Lots of these little devices are not able to do proper asymmetric encryption, but they all can do symmetric encryption. So think in kind of integrating the number of keys and the key exchange into your architecture to have a fully encrypted system and making the attack vector low. I want to just mention, I have thought about some of these things when I designed my system. Yeah. So this idea of the layered structures is very, very deeply embedded in the idea of what is going on around iotempower. So I always don't want to think in the single devices. I want to think in systems. Yeah, you always have kind of at least one gateway connecting several devices, and they fulfill a service together. It's not that one little node, one ESP is fulfilling a service, but the collection of these is fulfilling a service, and they might have another gateway which also does integration. This is why I like you to connect things weird over security channels together and think in bigger system how they work as one together. So this is the idea. Yeah, so you have somewhere a firewall to the internet, and you have different gateways behind the firewall, and you have a gateway behind the gateway, and only on the leaves there are the nodes. And on each of these connections between the gateway and the internet, you can do something with the security and implement new checks, do new updates. And this also removes the single point of failure. Okay, let's close the security topic. Let's be aware of the security issues in IoT and think about system architecture in the context, because I think that's very important. Don't think only from the security and privacy standpoint, but also think how you design a whole system. Think not only in programming devices, but also how the connections and the programming in the large is done. And yeah, let's prevent breaking the Internet of Things. And I have some research here, so if you really want to dig deeper, look at the references. So very quickly, before I go to the lighting, I want to repeat with you what you can already do. Yeah? So most of that stuff you see here, you can already control. So let's quickly go through that. You already know No, let's you go quickly through that. So each of you has downloaded that, I assume, yeah? I want you just to read through it and pick the ones you don't know. So just find the ones so that we can list them together. So just 5 minutes, and then I will help you with the devices which are there, yeah? Just very quickly go through this list and pick the ones you don't know, and maybe start already thinking about how these can be connected up. I can do a little bit Google, but kind of go through all these sensors and check off which ones of them you already know, and the actors, and which you don't. Good. Let's just go through it, and you stop me if there's something we don't know. So we have the area of temperature, humidity, and pressure sensing. So I think all of you have used the DS18B20 or Dallas sensor, yeah? Okay, no trouble here. Have you played with the barometer? Probably not, yeah? You have. So that's a little I2C device, and I think in your box is the BMP 180, and it gives you pressure and the temperature. So you can also use that as a temperature sensor. It's supported. So yeah, it's supported in iotempower. You can just use the BMP 180 and BMP 280 for kind of building a weather station, measuring some weather data here. And it's I2C, yeah? So you know I2C, how to wire up, 4 wires, and just putting it in. Have you seen the analog thermistor? So kind of analog device to measure temperature. I think some of you have tried to use it when we talked about temperature. Do you know how to wire it up? It's just 2 analog, and then you have to calibrate it against the temperature, and then you can actually also use that for measuring temperature, but most of the other temperature devices give you a more precise value. And the DHT11, measuring temperature and humidity, a 1-wire device, you also have connected. Good. You all remember my lecture, the MPR 121? Yeah, is a I2C device. This sounds fancy here, the TTB 223B. It's the capacitive touch button. Yeah, I think also most of you have used that one. It's kind of nicer than the other button in some ways because it's cool, because it's capacitive. Then the default button has this numbering. I think all of you have used the acoustic distance sensor, which has also 4 wires. And you have to be a little bit careful because it's a 5-volt, or often it is. Some are 3-volt devices, some are 5-volt devices. So you might need a voltage divider to connect that to the ESP8266. So have you worked with the optical distance sensor? This is this laser sensor we talked about. What type of device is it? How do you wire it up? It's an I2C device. Easy, connect 4 wires via I2C, then you can read it. Most of what it does is done by the library from you. So you have to use that in the Project 1 boat challenge. I think most of you have used the scale with the HX711 analog digital converter. It's just an amplifier. It's also basically I2C, but it's kind of, the libraries don't use proper I2C, so that's why you have to use it alone on its own bus. But basically, it's wired like an I2C device. Then we have gyroscopes. So we have both the MPU 6050 and 9250. Do you know what a gyroscope does? This gyroscope and compass, it usually you can get directions and kind of angles and acceleration in specific directions from it. Yeah, and both of these devices are I2C devices, so easy to wire up. Magnetic sensors. I think you all worked with the why the analog light sensor is there, I don't know. So that's, I think, a formatting mistake. So I hope you saw the analog light sensor. Also, just wire up to analog, then you can get light intensity. But there's also, which I actually forgot, there's a digital light sensor too, which you wire up via I2C. Then you played with the analog Hall sensor and the reed switch. So reed switch is not analog, reed switch is digital, but the Hall sensor you have to connect to the analog port and then see how strong the magnetic field is. Have you seen the light lock? Yeah, it's a little super tiny laser and a receiver, and it's kind of like a U, and you can put something in between the U, and then it breaks that, and you can read that digitally that happens. It's in your box. You can just use it, wire it as a normal input, and that works. So tilt switch works similar. It's this little thing you can flip around. Probably nobody of you has worked with the noise sensor. There's a little microphone in there, which you can also wire up analog, and you can use that to detect claps. But don't use it to really record anything significant or detect voice or sound. So it's kind of very crude device for detecting a noise level. Have you seen the infrared receiver? You know where to wire that. It's kind of a weird black lamp with a cross on the top. You know how to wire it up? It goes to the analog port, and then you can kind of receive signals an infrared emitter sends out. This is actually pretty cool, but we probably won't have time to do it, but maybe we want to do it in the final project. You can use that to measure infrared remote controllers. And then you can use, after you recorded that, use the infrared emitter to remote control real infrared devices. You can control your TV, your projector, your air conditioning unit with the infrared emitter if you record what the remotes are playing out. You've seen the obstacle sensor. I think it kind of has an LED and a receiver on there. And you can just use that to see if there is something coming close by, or is something nearby. Also wiring up analog, but it also needs power for the emitting LED there. There's a line tracking sensor. It's very similar, but it reacts on colors, so you can use that to follow a line on the ground if you build a little robot which kind of should follow a line. This one, I think, is also analog, but it has usually some kind of digital thing on there, so you can kind of see how it's dark and light to track that. So, you know the RFID RC522. That's an interesting device, because you will still start working with that. What is it for? I know that some of you have worked with it before. It's an NFC reader and writer. Cannot read every NFC card, but can read some default cards. Do you know how it's connected? With which bus? It's SPI, so lots of cables. Yeah, it's supported in iotempower. You just have to import it, but it's not documented, so you have to find the name in the source code. Yeah, but you can directly use it. The biggest challenge with this device is that you wire it up properly, because SPI has more wires than I2C. But it's pretty cool, so you will already today or latest tomorrow, you can get some of these devices from me and you can work with them. So if you want to build some logistics simulation in the last project, you might want to work with this. The PTF 8591, you might have seen mentioning me in the lecture. This is an analog digital converter which is not yet supported in iotempower. But yeah, talk to me. Maybe you have something which needs lots of analog sensors, then you might want to deploy that one. What about the smoke sensors? That's actually something we don't have enough time to. That would be nice if you Google yourself. So we have different type of smoke sensors, the MQ2, MQ7, and MQ3. I think the first and the last are actually relevant because they're really easy to test. Basically, the first smoke sensor is just a general air quality sensor. It reacts to a lot of things, and it's the one which is in your blue box. So you can basically take even the the gas of a lighter and just let the gas come in there, and then it will show that the air quality goes down. And there is a carbon monoxide sensor. I don't know if I want you to make experiments with that one. Maybe if you can blow from a candle or so against it, maybe you can measure something. And but maybe you want to play with the alcohol sensor. So that's basically can measure if you have alcohol in your breath and you breathe on it, how high your alcohol level is. Do you know how to wire these gas sensors? They're all analog sensors. So it basically takes some calibration, especially with the alcohol. You might, I don't know how you want to do the calibration. One is really drunk and one is sober, and and then you can define half drunk, quarter drunk, and in between. Here's the digital light sensor I was talking about, and there's also a flame sensor. I think I have forgotten. And the rainwater sensor you have already worked with. So acting, I think we haven't done too much with acting. We used the relay, but you have to definitely try out the servo motor, and careful, there are two motors. They're both kind of servo motors, but one of them is a hacked servo. Do you know what happens? So a servo motor basically gives an angle and kind of goes to that angle. What does the hacked servo do? It starts turning around in a specific speed. Yeah, it's like a DC motor, but not a real DC motor. Basically, the angle corresponds to the speed and how fast the motor is turning. So careful, they look the same, but some of them have 360 written on them. So these are the hacked servos. That if you want to kind of just go a small way, you have to switch them on and off. With the servo, you can just give an angle and it goes to that angle. Then we have the RGB LED you played with. You will now learn how to use these strips. I will show this here in class. You have worked with two types of I2C displays already in class, one for the dongle and one you used yourself. They're I2C, it's easy to wire up. So you have seen the small red laser, it's just power on, power off. You've seen the dual color LED and the flashing LEDs. All of them are just power on, power off. The infrared LED is exactly the thing you want to control with pulse width modulation, which is the analog to the infrared receiver. Yeah, so you also basically just switch it on and off. And you have worked with the buzzer. So I kind of mention here the computer because there's a lot of things you can do, for example, in Node-RED, or you can run Kodi or something on your computer for entertaining, for playing sound, and build connections to it. So don't forget that you also have cell phones and computer for your final project, which might be actors and sensors in your system, and can also be, simulators. You can also run all the MQTT simulators we built in the beginning on them. So as you see, we have an incredible amount of things we can use now. So I hope you can build a lot of the things you want to do in your project. So, and a lot of fun, which we haven't done yet, is kind of taking the LEDs one step further. So, and I will give Houston some chance to record that because I want some of the close-ups, and it's really hard for me to do them here on the camera, but I will mix it later so that you can actually see what I'm doing here. So, what I will start with, I have here a light strip, and it has 5 LEDs on there. And basically, I can program each of the LEDs on its own. And they usually are wired so with 3 cables. So they have a ground, they have a voltage supply, and a data line. But there are different ones. So there are ones which have 5-volt voltage line, and there are ones which have 12-volt voltage line. We will start with the 5 volts, and I will show you how to use them, and especially also how to build a little bit of an animation on them. First, we will just control each of the powers, each of the LEDs, but then I show you how you can make something cool like lightning or some kind of thing traveling over it or some rainbow running over it. That might come in handy for whatever you want to actually show in your class. I will today, for playing, I will give you these devices, but you need to get them back. Depending on your project, you can get back some of these, but today you can use a little shield. And this shield goes directly on the VMOS, but I will use it later in class too. But usually you get it like this, and the nice thing is they come as these super long strips, and you can cut them and then kind of wire them around the corner, and then you can easily build matrices and some things. Tomorrow I will show you different IoT projects, and one of them I built a 4,000 LED wall with a student for an arts project, and there you can kind of see these strips quite in action. But let's start with 5, yeah? So again, for that, okay, so let's fire up my infrastructure. I need an access point, make sure I'm not connected. Okay, great. So IoT access point. So you just need a Raspberry Pi. And I need an MQTT broker. And probably later I need Node-RED. Good, there we go. And then I go to my test folder. And we will work on node, or maybe here on this test node. So I start empty, but it's kind of a lot of test stuff here. Ignore that. So what is this in iotempower? Have an idea? So the single RGB LED was RGB_single. This is RGB strip. And see, it looks kind of similar like the single, but this is kind of complicated here. See what kind of weird stuff. So a bit careful if you work with these things. You have to understand the library I use. This is the FastLead library and has specific parameters. So in general, you can just look at my example and probably copy something, but if you want to use some specific LED types, you might have to look in here. And then we have different things for controlling it. You see again, set, brightness, and the RGB. The interesting thing is RGB has a push function, so we can do front and back, which already allows very simple animations. But so basically, usually I just need a data pin and the type of the LED strip to build one. So let's look at the example. So it's in examples, running node test. And so let's search for RGB symbol, and here are different RGB strips. Yeah, so we want to basically start with this thing here. Nope, and I copied more than I wanted to copy. So and also, you think they are all would be wired the same, so it would be RGB, but often the order is different. So let's start with RGB here, but different. So this one here is wired up to D5. So D5, and we have 5 LEDs here. We call it strip 1. So let's, as I have no idea which node this one is, I will do a serial adoption. Oh, I think I'm not in the IoT environment. So do a adopt serial. I have to be in test 1. And then we should make the light come up. Oh. We don't have a serial port. Let's try again. What? I think it still didn't connect. So out of some reason it doesn't detect our Vemos. So much about serial flashing. Yeah, maybe this one is dead. Looks not good. Try once more. Okay, we take a different Vemos. Oh, this one blinks. That's a good sign. It's probably alive. Or not. My computer just annoying me now. Ah, it's a USB port. We might be able to flash this today. There we go. In the future, I will deploy it. So there we go. So now it should work on this side. First, I need to wire it up again. So this is basically 5 volts and ground and D5, I said, yeah? So, I don't know, we have to kind of hang this so that you guys can see something. No. Let's look at it again. So this thing should be called strip 1 and it's not D5. Yeah, great. Great stuff. Let's do a deploy again, because 5 is different than D5. And that works. Great.
Maybe that's the wrong thing.
Good. So now let's try to send some color to it. MQTT send strip 1 RGB set. Let's see if this turns to some color. It might be not red. See? See that? So I think it's not RGB, it's some other order. So let's try. So red turns green. Let's do blue. Oh, blue is blue. So then I assume that green is red.
Yes, probably. Yes.
Yes. So we have to make a small tweak with this one here. So we basically have to say blue is correct. So it's GRB, yeah? GRB. So it should restart now, and then it should actually switch everything off. You doing that? Yeah, now it's rebooting. And now it's off. So now we should be able to, so you can set single LEDs here, starting at 1. Yeah, so I see set 1 to yellow. Then I set, oh yeah, we can do a little bit Brazil stuff here, yeah? We set 2 to green, yeah? And then 3 to blue. And so, and the cool thing is you can basically also now push something in the front. So imagine you wire up node red and you have something, and then you can slide over the color wheel and you basically push the colors into the front. With this you can get some interesting effects. So if I push in red, everything moves on there. So I can push in blue, everything moves on there. And black is basically off. You can also put in gray, which is not very bright. We can also send, as usual, kind of hex values there. And so it gets different colors that way. So with this, you can already start building some pretty cool small animations. I'll quickly show you the other device. So we, I switched this one off, yeah. Let's be nice. So because you will today work with these, which I sorted last night for you, which you have to give back to me after the lab. But if you like that stuff, see, and they are incredibly bright. And they're on D4. So we have to change that. But if you look into a smart light bulb, they look exactly like this. So we just move to D4, redeploy. Ah, and they have 7. Ah. Stupid. So that was wrong. It was D4, 7 LEDs. So glad that the deploy is actually fast. Come, reboot. It actually gets hot with the bright LEDs. Ah, now it's rebooting. It should switch off. And not always switches off all of them. So let's try to send color. So now it's all yellow, all blue, and it happens to be the same setup, I think. Yeah, like the LED strip I had there. So that is this. And I told you, I show a little bit the more advanced stuff you can do with that. Where do you start looking? In the example. So this was the example. So you see here, you can construct out of several strips, you can construct a matrix. So you see here, I define several strips here, and then I add this to the matrix. And the matrix you can actually use to animate. There's some kind of, like in games where you have a pixel screen, and then you have a frame rate where it draws and then shows. And of the same way, you can, in iotempower, program an animation, just like in a game. So you first construct the matrix, basically construct your screen, and then you can address each pixel in the screen and do some updates about this. See, following is a long example for the animator device. So let's kind of take all that stuff with the strips and kind of adjust that for us. And while I do that, I will explain that to you. I have only 5 minutes for that, because then I have to show you the project. So let's hope we manage to get that done quickly. So uncomment the whole thing here, please. No. Nah, didn't select the right stuff. Because
there is spaces between.
yeah, so okay, uncomment that. Uncomment that. Uncomment that. So there we are. You see, you can do things with rainbows. So that can keep the comment, and we keep the strip. I wonder if we should already switch to the big one. That's actually more impressive. No, okay, we'll start with the animation. So then I construct the matrix, and it's kind of 7 wide and 1 high. And then I can mount the strips at different points in the matrix. I leave all that. But now I have to work on some things. So you can then attach, so that the interesting command you want to look at is this here. So you see that there's an animator object which uses the matrix you just defined. Did I define it correctly? Here's the matrix. And I can also define it this way. This is the way you know it. But then I have to access the matrix object like this. So I give a frame rate, how often this show routine is called, and then you can define a frame builder, which is basically drawing stuff in there. So now we'll simplify that one now, and just have here, we'll just use a frame counter. And if the frame counter has a specific number, then I will start animating stuff. So I will just say if frame counter is bigger than 0, then we do some fun stuff. And what I will do now is I will just do a simple fade, I think. So I will just fade out. So if you check the matrix function, you will see that there are different things you can do. You can do a rainbow here, you can scroll, or you can fade from one color to another. And fade should give me, so I'm just fading the whole thing. And this is, I think, the LED number. So we take all that, and then we decrease the frame counter if it's bigger than 0. Frame counter minus minus. So we leave the command. We leave this as a last command. And we don't have this function. We just set in here the frame counter to 20, and we need to set our strip to a specific color. I have to check how I do that. Let's start with a rainbow. This thing is 7 long. And that should be it. We don't need all that other stuff here. Only thing we need is the frame counter. So, let's see if we can deploy that. Unfortunately, I tricked myself. Yeah, no, I have to consisting. If I don't define matrix as a real object, I have to access matrix with this in construction. Some of you might have seen that. So of course you can do all the programming, all the pixels from Node-RED, but you can imagine that the latency might be not as great. Strip 1 is also wrong. That's better. So, before we try that, I will quickly present the project to you. And then we will test it out, and the big strip we have to try out in the beginning of next class. So, in the second final project, you are supposed to outline an IoT scenario covering at least 4 different domains, which mostly can be implemented with the existing hardware. We have a lot of hardware. So domains can be, for example, logistics, comfort, entertainment, wearable computing, health, arts, security, privacy, and more. I don't want to have residential home automation in there, because that is another class. So I keep that out. But if you want to do something in a building or so, that's fine. Fully specify the scenario into a playable pitch, or story, you could say here too, which will be enacted by all team participants in the final presentation. Everybody should have a role in there. Realize this scenario in soft and hardware. Document all the development, including problems. Specify who has done how much in respective portfolios. Wrap it into a sales pitch plus presentation, including the playthrough with real hardware of the scenario. For non-working parts, create respective mockups. Practice and record the scenario playthrough as a video, and this is what you submit. Submit the video of the pitch plus the technical explanation. It doesn't need to be a pitch for a product. It can be also kind of a community initiative. Yeah, it can be also something where there's just a benefit but no direct monetary outcome. If you want to do a learning activity or something. I have to approve that in the next 3 days. Yeah, so I will now in the labs kind of walk around, and you will show me your versions of the scenario, and we will kind of refine it together. There are deadlines on the syllabus, and there will be deadlines in Moodle for when you submit this stuff. Yeah, so the video The total video should be 15 to 25 minutes long. From there, 10 to 15 minutes should be a story pitch, and 5 to 10 minutes should be technical explanation. So let's now see. And you need to share it in a way, so probably in Moodle, share a private link so that everybody here in class can watch your movie. You can also be public. That would be nice, but you don't have to be public. But you have to at least be able that your classmates can watch it, because everybody has to rank the movies in the end for the final reflection in the portfolio. So let's quickly see if I was successful here. And so that should be, I should now be able to send to the anim topic fade. And it probably doesn't work, but let's see. Yeah, at least I get the rainbow, but it doesn't fade away. Okay, we get the rainbow. Let's quickly see if I can fix the bug, but that looks good. I don't know, maybe I fix it in the labs and show you the little thing in the lab, but I think it cannot be a big mistake. I think I might not fade the right thing here, so I have to look at the parameters of fade. So it might actually at the moment only do one LED or one not existing LED. So I will show you that maybe in the lab and the light strip tomorrow.